All right, here's a couple of problems from 7.8. And these are from the homework. I'll start with number 11. It's got 0 to infinity, x squared divided by square root of 1 plus x3, x to the x cubed, right? All right, so it's a fairly straightforward calc 1 integral, except for the fact that it has the 0 to infinity. So there's really two separate things to do. One, take the antiderivative, and two, take the limit. So I show the work the way the book does. You need to take the limit as part of the work. So limit as t goes to infinity, integral 0 to t x squared divided by square root of 1 plus x cubed dx. But then it's okay to do that antiderivative a little bit on the side, so to speak. It'll be a u substitution, so we want u equal 1 plus x cubed. That's a good guess because 1 plus x cubed is under the square root, and you immediately notice that x squared is almost the derivative of x cubed. Specifically, it's du is equal to 3x squared dx, and then 1/3 du is exactly x squared dx. So I'll use all that to work out just the integral, and then I'll take the limit again. To save space, I'll write limit as t goes to infinity after I take the integral. So from the u substitution, I get a 1/3. So this would be just this much of it is equal to integral. This is x equal to 0 to x equal to t. Just remember, I need to put back in x before I actually plug in the 0 and t. This is 1/3, and this is du, 1/3 du from x squared dx, and then the square root of 1 plus x cubed will be the square root of u, but it's u to the negative 1/2. Negative 1 divided by 2. And you can take another step in between there if you need, and write the square root as positive 1/2, but in the denominator, so it's negative 1/2. All right, and then this lets me do the antiderivative. So I get u to the positive 1/2, adding 1. Then divide by 1/2, so times 2. So there's a 2 and the 3 from the 1/3 there. And that's going to be evaluated from x equal to 0 to x equal to t. But I need to put back in what u is. It's 1 plus x cubed. So I have, and now I should probably go ahead and say this is the limit as t goes to infinity of, and then I have the 2/3. I have 1 plus x cubed to the 1/2, which would be same thing as square root. It's okay to leave it as power 1/2 if you want, but you can put back in square root here if you want to as well. And that goes from 0 to t. So it's equal to the limit as t goes to infinity, and plugging in t and plugging in 0. So when I plug in t, I get square root of 1 plus t cubed. With that 2/3 on there. So I'll need to take the limit of all of this. when I plug in 0, I get the square root of 1 plus 0. So I'll have minus 2/3, and plugging in 0 there gives me the square root of 1, so just times 1. I'll show it so you can see that I did something. Plugged in the 0, got square root of 1 equals 1. And so now I have 2/3 square root of 1 plus t cubed minus 2/3. I'm taking the limit as t goes to infinity. Well, this is where I can just plug in the infinity. Infinity cubed is infinity. Infinity plus 1 is infinity. Square root of infinity is infinity. So you can plug in the infinity here for the t, and then adding or cubing it, adding 1, taking the square root, still infinity. 2/3 of infinity is infinity. And finally, infinity minus 2/3 is infinity. So you basically get, depending on how many times you want to write it, infinity minus 2/3, which is equal to infinity. So final answer is infinity, which would also mean that this is called divergent. Or you can say it diverges. All right. So that one's divergent equals infinity. Also, if you get negative infinity, you would say that would be divergent as well, but this one's positive infinity.